Dear students, having discussed the idea behind One Way Anova, now we discuss the logic behind One Way Anova. Now, the reason for the word variance, analysis of variance. The reason for the word variance in ANOVA is that the procedure for comparing means analyzes variation in sample data. As we have discussed in the previous class, we cannot use a pooled t-test when there are more than two populations of a given variable. So, when we have to compare more than two population means we use ANOVA. And what we are discussing now is one-way ANOVA. One way because we consider only one factor, as we have discussed in the previous class. One factor, the region, with the 4 levels to classify the population. And the variable of interest was energy consumption. So now what I say is, the word variance in ANOVA is due to the fact that to compare means we are using variation in sample data. And to examine how this procedure works, let us consider independent random samples are taken from two populations. Independent random samples are taken from two populations having means mu1 and mu2. Having means mu1 and mu2. Suppose also that this mu1 and mu2 are unknown. Suppose that the sample means are 20 and 25. The sample means are 20 and 25, and based on this information, can we conclude that mu1 is not equal to mu2? mu1 is not equal to mu2. To answer this question, we must consider the variation within the sample. We have to consider variation within the samples. Variation within the samples. As an example, consider population 1 and population 2. The samples are 21, 37, 11, 20, 8, 23. X bar 1 is equal to 20. Then 24, 31, 29, 40, 9, 17. X bar 2 is equal to 25. Suppose that these are the samples generating the means x bar 1 20 and x bar 2 25. But as you can see, using this sample we cannot say that mu1 is not equal to mu2. We cannot conclude that mu1 is not equal to mu 2 as it is not clear whether the sample differences x bar 1 20, x bar 2 25 between the sample means is due to differences in population means or a variation within populations. As you can see, these values are different due to variation within, not because population means are different. So, two populations with mu1 and mu2, samples generated x bar 1 20, x bar 2 25, but using this we cannot say mu1 is not equal to mu2 because this difference is not because mu1 is different from mu2. As you can see, just to go through this, or you take a dot plot of this, you will see that this difference is due to variation within the population, not because of differences in population mean values. Now you consider another set. This time it is 21, 21, 20, 18, 20, 20, 25, 28, 25, 24, 24, 24. Again x bar 2 is 25, x bar 1 is 20. Now, if you compare this with this, then we can conclude that mu1 is not equal to mu2 from the sample information because now this is due to differences in population means. As you can see, the variation within the samples or within the population is low. As you can see, not much variation between sample observations. Here also, not much variation between sample observations. Now in this case, we can conclude that mu1 is not equal to mu2. The difference between sample means is due to difference between population means, and it is not due to variation within the populations. And this example reveals the basic idea behind one-way ANOVA to compare several population means. To compare several population means. To explain this, suppose that we take independent samples. Suppose that we take independent samples from k populations or n populations, whatever it is, from all the populations under consideration. Compute x bar 1, x bar 2, etc. up to x bar k. Then, if a variation among sample means is large relative to variation within samples, if variation among sample means is large relative to variation within sample. Variation within sample, as you can see. Variation between samples, as you can see. So, if a variation among sample means is larger relative to variation within samples, conclude that means are not equal. That is, variation among sample means large relative to variation within. We conclude that the means of the population are not same. mu1, mu2, etc., mu k are not equal. This is the basic logic behind one way ANOVA. We compare variation among sample means with the variation within samples. Variation among sample means is compared to variation within samples. And a conclusion is reached regarding whether the population means are same or different. Now, to make this procedure precise, we need a quantitative measure of variation. We need a quantitative measure of variation among sample means, quantitative measure of variation among sample means, and also variation within samples. Variation within samples. So, to make this precise, we require a quantitative measure of variation among sample means, variation between sample means, and variation within samples. Also, we require an objective method to decide whether variation among sample means is large relative to variation within samples. Whether variation among sample means is large relative to variation within samples. We have to decide objectively whether variation among sample means is large relative to variation within samples. A comparison will give rise to a test statistics, and the decisions are taken on the basis of the value of the test statistics. Since we are considering variation among sample means and variation within samples, the name one-way analysis of variance ANOVA. One way because we consider only one factor. Analysis of variance because means are compared by comparing variation among sample means and variation within samples. So, the name one-way ANOVA. And this is the logic behind one-way ANOVA.